Hello, this is a lecture on truth tables. Before I show you how to construct a truth table, I need to discuss two preliminary matters with you. One is, what is a statement variable? A statement variable, such as P, Q, R, S, is something that can stand for any statement, simple or complex. In propositional logic, we've seen that a statement is a capital English letter. Well, a statement variable is a lowercase English letter. So P, the lowercase letter P, can stand for any statement, simple or complex, in propositional logic, such as P, Q or S, T then R or M, etc. So each of those, P, Q or S, T then R or M, are considered substitution instances. So a statement variable is a lowercase letter in English that can stand for any statement in propositional logic, simple or complex. This is important because when we do our truth tables, I will be using statement variables, at least when I show you how to construct a truth table. And when I show you what the meaning of our logical operators are, the meaning is, I will use statement variables. So you just need to know that when I have a statement variable in there, it can stand for any statement whatsoever. And so then, once you know how to construct a truth table for a statement variable, you know how to construct a truth table for any statement whatsoever. We also have statement forms. This is a pattern of statement variables and logical operators, such as not the case, that, P, or Q. So if you see that, just know that the P and the Q in there can stand for any statement in propositional logic whatsoever. So what is a truth table? This is an arrangement of truth values for a truth functional compound statement. So we saw that a truth value is truth or falsity, T or F. And truth values are of truth functional compound statements. So a given truth functional compound statement might have the truth value true or false, represented by T or F. Truth tables a truth table shows every possible truth value for the compound statement. So let's just suppose it's not P. Not P can either be true or it can be false. That's every possible truth value for the compound statement. Once you start comparing statements and giving all the possible combinations of truth values for them, it gets much more complex than just T and F. It might be TTTF or TFFF or TTTT, etc. A truth table shows how the truth value of a compound statement is determined by the truth values of its simple components. In truth tables, we are using truth functional compound statements, which I gave a lecture on. Truth functional compound statements, the truth of them are determined by the truth value of the statements within the compound statement, as well as the nature of the logical operators within the compound statement. The truth value is determined solely by those things. And a truth table can show you how the truth value of a compound statement is determined by its components. And then finally, a truth table provides definitions of our logical operators. Our operators are the wedge, the dot, the tilde, and I'll be giving definitions for those. Via truth tables. So let's construct a truth table for the compound statement, not P. Remember, P is a statement variable, and it can stand for any statement, simple or complex. The compound statement goes on the top left of the table. The component statement of the compound statement goes on the top left of the table. So the component statement is P. It just means that it's the simple statement that appears within the compound statement. The component statement is P. It goes on the top left of the table. The entire compound statement goes on the top right of the table. So not P goes on the top right, and the simple statement that is part of the compound statement goes on the top left. And then all the possible truth values for the component statement P, they go on the left bottom of the table. These we call the truth value inputs. So P could be true or it could be false, and those are the only possibilities, true, false. So we list them with T first on one row and F first on another, F second on another row. To finish out the truth table, we need to give the truth value outputs. So the outputs, which are determined by the compound statement, not P, go on the bottom right. So we see that whenever the component statement P is true, the compound statement not P is false. Whenever the component statement P is false, the compound statement not P is true. So if you had something like Obama is not president, that would be the compound statement. The component statement is Obama is president. Whenever the statement Obama is president is true, the compound statement, it is not the case that Obama is president, is false. Whenever the component statement Obama is president is false, the compound statement, it is not the case that Obama is president, is true. So the negation just flips the truth value of the component statement, the statement it's negating. So for each truth table, you will have the compound statement, which appears on the top right, its components, which appear on the top left, the truth value inputs, which appear on the bottom left, and the truth value outputs, which appear on the bottom right. And the outputs are determined by the nature of the truth functional compound proposition. In this case, not P. That's how you construct a truth table. If you have any questions, let me know, and I hope you have a good day.